Today I'm going to be continuing my discussion of the early 1800s, specifically focusing on the Industrial Revolution and the impact it has on the American economy. When I left off last time, we were talking about this new Republican agenda, economic agenda, during the years following the War of 1812, known as the American System. And in addition to banking and tariffs, Republicans are going to propose a series of internal improvements. This is basically primarily transportation improvements that are going to take place during this time period. Today we would refer to this sort of thing as infrastructure. It includes today phone lines, utility lines, water, sewage, roads, bridges, dams, all these sort of things, the power grid, all of these things are categorized as infrastructure. But in the early 1800s, we're talking specifically about roads and canals, and then later on railroads as well. So these internal improvements, part of this new Republican agenda, an attempt to build American prosperity and set the stage for growth and expansion. What will happen is that as this debate over internal improvements starts to take shape, a couple of old ideas are going to come to the surface, particularly in who's going to pay for these improvements. Originally, the Constitution, we talked about how it is interpreted will be the kind of the center of the debate between political parties, with Federalists, the old Federalists, having a loose interpretation of the Constitution, and the Republicans having a very strict interpretation. This, when the issue of internal improvements comes up, we kind of go back to this main issue of how the Constitution is interpreted. Advocates of federal funding for internal improvements, roads and canals and so forth, will argue that the necessary and proper clause justifies the federal government getting involved in these types of projects. People who interpret the Constitution more strictly will argue that since the Constitution does not specifically authorize the federal government to pay for or fund these types of projects, then these things should be left up to the states. So even though the Federalist Party doesn't exist as a party anymore, a lot of these ideas still are present. This idea of how to interpret the Constitution strictly or loosely, specifically with regards to internal improvements. Many in Congress believe that the federal government should get involved in funding or actually constructing these improvements. A lot of the people in Congress don't agree with this. They think that the states should have sole responsibility for these sort of things. Presidents Madison and later Presidents Monroe at the time both tended to lean more toward the strict interpretation, whereas several bills proposed by Congress for these types of funding were vetoed by both Madison and later Monroe. What ends up happening is that they decide on a kind of a balance, a compromise, and this becomes kind of the unofficial policy of the federal government regarding internal improvements or infrastructure. If the project benefits more than one state, such as the National Road we're going to talk about here in a minute, which stretches across multiple states, then the federal government can provide funds to help pay for it. If the project it only benefits one state, or the project, this internal improvement, this infrastructure project, is contained entirely within a single state, then that state will pay for it, and the federal government will not get involved. And that'll be the case with the Erie Canal. We'll talk about that a little bit later on today as well. So this becomes kind of the standard. In fact, James Monroe helped set this precedent. Projects that supported the nation, he tended to support those projects, federal government funding for those projects. Projects that only supported or benefited one state, Monroe tended to veto those proposals. So these internal improvements, specifically with regard to transportation, federal government is going to get involved with some of these projects for the first time. Up until now, we haven't seen the federal government take any kind of an active role in building or improving the nation's economy, or you physically get involved with any projects of this nature. Most of the things that fall into this category have taken place on strictly a local level. But for the first time here in the early 1800s, federal government will get involved, and it'll set the precedent for years to come. Even today, funding is made available by the federal government for various interstate projects. So first up is our national road. Begins construction in 1811, and will be the first leg will be finished in 1818. And looking at our map here, this first section of the national road, stretching from Cumberland, Maryland to Wheeling, Virginia. This is the first section of the road that will be built from 1811 or to 1818. After 1818, and of course, every year following that, this road will be extended on out through Ohio, Indiana, and Illinois, eventually onto the Mississippi River. But for now, this initial phase, the part that Congress is most concerned with at this point, is this initial stretch of the road. And this is important here. Geography is again part of this particular issue. When we're talking about transportation, geography is very important. Prior to this, most of the travel, and even after this, a lot of the travel is going to still heavily rely on the rivers in order to facilitate travel, both passenger travel and goods and cargo and so forth. The Potomac River that empties into the Chesapeake Bay is navigable all the way up to Cumberland, Maryland. And of course, the Ohio River, as we've discussed many times, is already a major waterway in the interior of the United States. This national road, this first segment of the national road, will connect Cumberland, Maryland, which is on the Potomac River, to Wheeling, Virginia, which is on the Ohio River. And this stretch of road basically crosses the Appalachian Mountains, the biggest physical barrier between our coastal cities and our frontier farming communities. So this road is very important. It creates a vital link between the people living in the Ohio River Valley and the cities in the Chesapeake Bay area. Washington, D.C., Baltimore, and several other cities in this area, very well developed, starting to take on a kind of an urban character. And our frontier farms and small towns, which are now going to be more directly connected to our eastern cities. So this national road is a very important project, a very important link now between these two parts of the country, which are growing very rapidly. The Ohio River Valley at this point is expanding very rapidly in terms of settlement and development and so forth. This direct link now will help speed up that process, and it'll help make these areas more connected to the cities of the east. So eventually, of course, we'll see this road being extended on throughout each state. And because it traverses several states, the federal government will partially fund this national road. And of course, wherever the road passes through a particular state, then that state will help provide the funds as well. So for the segment that crosses Ohio, the Ohio state government will provide some of the funding for this road, and then of course the federal government will provide additional funding. And this pattern holds true even today. That precedent is established here with the national road, our first major federal infrastructure project. And we're talking about this road. It's important that we acknowledge that this is not just some kind of a little primitive wagon trail scratched out through the woods. This is going to be a major construction project, the first of its type to happen on this scale in America. Engineers and surveyors and construction workers will be involved with this project all through its process. It'll be carefully planned and designed using a lot of techniques, as you can see here, this illustration, that date back all the way to ancient Rome. Surveyors will plan a route through this region that will follow the gentlest grades, and this is important because Our wheeled vehicles, as far as overland travel is concerned, wheeled vehicles, carts and wagons pulled by horses, is still the primary method of overland transportation. And a team of horses can only pull so much weight. The steeper the hill, the less weight they can pull. So for this road to have any effective usefulness, it's going to have to follow a very gentle grade. And so surveyors and engineers are going to be involved from the very beginning of this project, ensuring that this road follows a generally gentle grade through the mountains. And of course, to ensure the road lasts longer than one season, to prevent erosion from the rains and winters and so forth. It'll be graded out smoothly. They'll cover the road bed with varying degrees of rocks and of course smaller and smaller grades of rocks and gravel, and which will be compacted and formed into a road bed that's going to last many, many years. In fact, today there are still parts of the National Road that are still in use 200 years after this project was initiated. So that's kind of a testament to how much effort was put into these roads. They were made to last. This is not just some kind of a little provisional trail. They're going to really pull out all the stops when constructing this project. In addition to the National Road, and of course the National Road, starting in Cumberland, Maryland, this is not going to be the only road under construction. I use it as an example because it was the first major infrastructure project that the federal government became involved in. There will be many other roads built in various parts of the country using similar designs and techniques, and of course funded in similar ways. So the National Road is just the first, and as such, it's the most important. A few years after the National Road opens, the Erie Canal will open. In 1825, construction began on the Erie Canal about it was about 3 years earlier than the National Road. About 1817 was when the construction on the Erie Canal began. So there's a little bit of overlap. The crews are working on the National Road right about the same time that the Erie Canal is under construction. So we've got a couple different projects going on simultaneously. In the case of the Erie Canal, however, this canal is going to be contained entirely within the state of New York. It's about 300 miles long, connecting Albany, New York, which is on the Hudson River, to Buffalo, New York, which is on Lake Erie. Taking a look at our map here, here's the Hudson River, which comes out right at New York City, and it is navigable all the way up to Albany and further north. So basically, we're connecting this Hudson River across the central part of New York to Lake Erie, which is located at Buffalo. Now, so essentially what we're doing here is, in much the same way that the National Road connected the Ohio River Valley to the Chesapeake Bay, the Erie Canal is going to connect the Great Lakes area to New York City. If you look at the inset map here, we see our Great Lakes area, which is already a major transportation route to the interior of North America. We're connecting that now directly by way of the Erie Canal to New York City. And of course, like I said, the Hudson River is already a major waterway. So this is going to create a very significant shortcut. To get to the Great Lakes area from New York City, which is a major trade center at this point, you need to sail all the way up the coast of North America and down the St. Lawrence River into the Great Lakes. A journey which takes many weeks to take place. Once the Erie Canal is done, it's going to take a little bit less than a week to get from New York City to Lake Erie, which is a very significant reduction in travel time. What you'll also see here, there's numerous towns that are going to pop up along the way. Some of these towns didn't exist prior to the Erie Canal. They will be built. These towns will be built to service the canal along this route to facilitate the transport and delivery of goods. A lot of the farms in this region will now have easier access to New York City, which is where the markets are. So we'll see a lot of development taking place in this region as well. Even though the route was intended to connect New York with the Great Lakes, it's going to bring a lot of improvement and prosperity to places along this route that didn't exist before. Now it'll be possible to settle in these areas of central New York, which had been largely undeveloped, because now there's easy access there. People will be more likely to move out into this area and establish farms, and of course they'll have easier access to the markets where they can sell their farm goods. So we'll see a lot of towns being built up along the route of the canal. How does the canal work? Basically, the Erie Canal is essentially a ditch, a man-made ditch across the middle of New York. Now, it's not like a river. There's no current in the canal. A canal is still water, and it's on purpose so that there's no current to sail against. It's easy to move a boat one way as it is to move another way, because there's no current to force the boat moving in one direction. These boats, these barges, which can carry many times the amount of cargo as a wagon, a horse-drawn wagon, but they'll still be powered essentially by the same team of horses which pulled a single wagon. The same team of mules or horses can pull a large barge fully loaded with cargo. So basically, along the length of the canal, there will be a small little road where these horse teams and mule teams will pull the boats along their route. And this is kind of one of the reasons why so many towns will pop up along the canal route, is because these horses, this team of mules or horses, can usually go about 15 or 16 miles over the course of a day. So there's the towns will pop up about every 15 or 16 miles or so in order to facilitate the feeding and stabling of these horses and mules. And of course, they can switch out teams, and the boat will stay loaded, and they'll just switch out for fresh horses or mules, and then the boat will continue on the next day along its route. And traffic will move both ways along the canal, as you can see here. So basically, this is going to be a man-made ditch across the state of New York. Here we see another illustration of what the Erie Canal looked like in its heyday. Of course, this is a good illustration too of how the towns will grow up around the canal. In these towns will be not only the servicing for the horses and the crews of these canal barges, but also a marketplace for goods being sold out of the cities. So goods being produced and sold in New York will be transported out here to the frontier, and these towns will serve as kind of a collection point for farm products and a distribution point for manufactured goods coming from the city. So we'll see a lot of economic activities in these small towns along the canal route. Some of them will grow into significant cities as well. And we see here this barge pictured is configured to carry passengers as well as cargo. So some barges will be open top barges carrying a cargo, farm products. Some will be enclosed to facilitate transportation of passengers. So the Erie Canal will be not just a route to distribute farm products and trade goods, but also a transportation route for people as well. The Erie Canal is not all on one level. The map is kind of misleading. It shows a long, unbroken route across the state of New York. What ends up happening, though, is that in order to traverse uneven terrain, the canal uses a series of locks. So to get over hills and so forth, they will use these locks to basically raise the barge from one level up to the next level. So the canal will go along for several miles at one level. Again, there's no current here. It's like a pond or a ditch. But to get uphill, instead of unloading the boat onto wagons and pulling it up the hill and reloading it onto another boat, they just build this series of locks, which basically are gravity fed, draining the water from the upper level into the lower levels, and at the same time raising the boat up each step till it's ready to the next level. So the boat can remain loaded from its origin to its destination and still traverse uneven terrain. Some of these locks will be engineering marvels, even by today's standards. Some of them still exist today. These constructions were such a large project, and such large cities grew up around them, that it was not really cost effective to tear them down once the canal was obsolete. A lot of these locks are still left there today. In fact, certain areas of the canal are still in operation. It's more of a living museum or a tourist attraction today. It's not really considered a commercial waterway as it was in its past. So the Erie Canal, like the National Road, was designed and intended to connect the East Coast cities with the interior of North America. So with the roads and the canals, we've got the beginnings of a transportation network starting to take shape, but it's not complete yet. There's going to be other pieces to this story too, and that's where the story of the railroads begins. Now, in the early days of railroading in America, it was very primitive. 1835. This is a map of the U.S. railroad network in 1835. As you can see, it's not really what you consider a network per se. It's mostly just small bits and fragments of railroad lines scattered throughout various parts of the nation. In most cases, these small railroad lines, they serve a mine or a quarry or some other small-scale operation. None of these lines are considered long-distance transportation route. Now, in this area between New York and Washington, D.C., this little corridor right here, you can start to see there is some evidence of a long-distance connection between some of these major cities, New York, Philadelphia, Baltimore, and so on and so forth. But it's still very fragmented and very local. There's no such thing as what you call a national network. But that's going to change very rapidly. Also, in the early days of railroading, the technology is still very primitive. In most of these early small fragmented lines, we see rail cars being pulled by horses. Basically, what they've done is they've built an enlarged version of a covered wagon, and they put flanged wheels on it so that it'll roll on the rails, but it's still being pulled by a team of horses. So we're still looking at very primitive technology here. It's a lot faster and smoother than a horse pulling a cart over uneven terrain, but it's still very limited in what it can do. And this is basically America's first railroad, the Baltimore and Ohio Railroad, and this is what it looked like. This artist woodcut from this era. This is what it looked like in 1830, which is pretty much the birth of American railroads. Later on, though, we're going to see the incorporation of steam power on these locomotives. So self-propelled locomotives powered by steam will be pulling some of these trains. And what we're looking at here is an early steam locomotive, one of the first practical designs of a steam locomotive. And this is actually a British design. And it's important to remember that the Industrial Revolution begins in England and spreads throughout Europe and then later to the United States. So no big surprise that steam technology, of course, originates there as well. Now this design was it was not the very first steam locomotive, but it was the first practical design, one that could be reproduced with very predictable and consistent performance. They called it the Rocket, so named because of it sped along the rails at the amazing speed of 25 miles an hour. Again, this is 1830, so you have to remember, everything is relative. Today, trains travel well over 100 miles an hour, 200 miles an hour in some places, but 25 miles an hour in 1830 was considered quite fast. But even though the better designs are coming out of England at this point, in America, we still are trying to do things on our own. We don't want to depend so much on imported things. Whenever possible, we try to produce things on our own. And that's the case with the B&O Railroad and a guy named Peter Cooper, who designed America's first steam locomotive. The Rocket, of course, designed by British engineers. The Tom Thumb, so nicknamed by Peter Cooper because of its small size. At any rate, this is the first American locomotive. It's not a very good start. This locomotive, Cooper's Tom Thumb, was very rickety and fragile and flimsy. It was kind of slapped together in his own little workshop using spare parts and bits of junk that he had collected over the years. It did work, but it was not very efficient and it wasn't very fast and it had a tendency to break down all the time. However, it was an original American design, and it's an important first step in what will become a long tradition of American design and innovation. Funny story about Cooper's first locomotive. When he introduced the idea to the B&O Railroad, there was a lot of skepticism. They're like, okay, that thing looks like a piece of junk. It's never going to replace the horse as a means of powering these trains. So Cooper offered to test it in a race. Let's put a horse-drawn cart against his steam locomotive and see which one wins. Basically, and this takes place 1830, 1831. Initially, of course, the locomotive pulled out in front of the horse, and it looked like it was going to win, but he started suffering mechanical difficulties. It starts falling apart. He's repairing it as he's rolling down the tracks. It was kind of an embarrassing defeat for Cooper and his steam locomotive because the horse ended up winning very easily. But again, it was an important first step. Innovation and changes will bring this technology to the point where it is efficient, it is productive, and it will become the standard. A few years later, another railroad company, the Mohawk and Hudson Railway, will come up with their own design, this DeWitt Clinton locomotive. As you can see, it looks very similar to the British design, and it's much more efficient and much more reliable. And we can see here another example of these carriages that look like they used to be horse carriages, but now they've been converted to run on rails. And this will be a much more efficient version of what we're looking at from the B&O Railroad. What's unique too about this Hudson and Mohawk Railway is that it will compete eventually directly with the Erie Canal. It'll follow a similar route from Albany, New York, out to the Great Lakes. So it doesn't parallel the canal directly because trains have to navigate terrain in a different way than the canal. They have to it's harder to get across mountains and so forth. They have to build bridges and tunnels and so forth. But roughly this route of the Mohawk and Hudson Railway will compete directly with the Erie Canal. So we see another unique feature of American industry starting to take shape here. Direct competition between two different industries, the canal industry and the railroad industry, now both offering various speeds and prices for moving goods and services and people onto the frontier from the East Coast. So now we have options too. It's not just if you want to get from New York City to the Great Lakes, you have options. You can go by boat or you can go by train, depending on how fast you need to get there or what type of cargo you need to get there. It was more expensive to ship cargo on the rail because just in terms of volume, the trains couldn't carry as much as the barges, so it was more expensive to ship cargo by rail, but it was much faster to travel. So if you were just traveling by yourself, or you and your family were traveling to the frontier, you might elect to go on the train. If you were a merchant and you had a lot of goods to ship from one place to the next, you'd probably go with the canal. In the early days of railroad, too, as is the case throughout history, anytime new technology starts to become popular, it's not popular universally. And the railroads will see a lot of kind of pushback from society in terms of criticism and opposition. This poster is a kind of a public service announcement that appeared in Philadelphia in 1839. Basically, this PSA is criticizing all the negative aspects of the railroads. They're dirty, they're noisy, they're dangerous. The railroad tracks, and this picture is showing a train coming right down the middle of Main Street, which was often the case in a lot of the small towns that grew up around the railroads. The train tracks literally went right down the main street. So for pedestrians and horses and carriages, this does create somewhat of a safety hazard. And this public service announcement is calling attention to those hazards. It's a lot of public outcry. Not just that, but more subtly, I guess, when you read the fine print here, this advertisement is also criticizing the fact that this small town of Philadelphia is going to eventually become a suburb of New York, which of course it is today. New York and Philadelphia are connected directly by train. You can get on a train in Philadelphia and arrive in New York and never touch the ground. So there was concern about that even at this in these early years, that small towns would be eventually absorbed into the orbit of these larger cities. So there was not universal enthusiasm toward the railroads, even though the railroads were, in the big picture, they were beneficial to the nation, but there was still a lot of people who tended to criticize them. Finally, when we started out in 1830, 1835 as just a small, disconnected, fragmented series of short railway lines, by the time we get to the Civil War in 1860, 1861, we see what is now a true network of railroad lines connecting most of the major cities in the country. Especially in the north. North of the Ohio River, you see here the density of railroad lines is far greater than in the southern states, where in many areas the lines are still somewhat fragmented and disconnected. This will be an important factor when we get to the Civil War. The industrial and transportation infrastructure of the North gives it a very distinct advantage in terms of tactics and strategies and warfighting ability than in the South. So we'll see that play out and become an important factor once we get to the Civil War. But we can see that these patterns of transportation tend to reflect the patterns of development that we've already seen taking place over the previous couple of centuries, with larger populations and more towns developing in the north than in the south. It's no surprise then that a more extensive transportation network will also grow up in the north rather than the south. Our last piece of our transportation network, our internal improvements, are we're kind of getting back to river travel here. Rivers, throughout this time, despite the fact that we've got roads being constructed, canals and railroads all under construction, all contributing to this emerging transportation network, most of the travel still takes place on the river during these early years. But since the Industrial Revolution has brought new technology into the picture, we're going to see that being incorporated into river travel. A guy named Robert Fulton in 1807, an American inventor and innovator, he is going to combine the steam power with current ship designs. Basically, this the Clermont, Fulton's first steamboat in America. Robert Fulton's idea here to put a steam boiler which drives a paddle wheel on a boat, allowing the boat to move freely in any direction without the benefit or necessity of wind. So this boat can sail against the current on the river as easily as it can float downstream with the current, and of course there's no need for wind. Now you see here the fact that this boat still has the rigging for sails suggests that while Fulton is an innovator and he's hopeful that his new design will become the standard, he's planning for the eventual breakdown of this boiler and the wind power to bail him out in an emergency. So we see it's not an instant conversion from wind power to steam power suddenly and completely. There's a transition. Even steam-powered ships will still be rigged with sails in the event that they run out of coal or wood to burn for the boiler, or that something breaks down and they end up having to rely on traditional means of power. So and this is the case with all new technologies. There's often a transition period or a period of overlap where two technologies will exist side by side, the old and the new, often being integrated for a period of time before the old finally gives way to the new. Taking a look at this map, we see a map of roads and canals that are developing alongside our railroads. There's really too many pieces to put all on one map, so that's why we've got two separate maps here. But you can see here's our national road that we talked about a few minutes ago, and our Erie Canal that we just finished talking about. But in addition to these, there are many other canals. By the time we get to 1850, the northern states are spiderwebbed by various canals and roads, in addition to the railroad lines that we looked at a minute ago. So we see a very complex and varied transportation network being constructed during the early 1800s, the first half of the 1800s. In the north, you can go from any city to any other city in the north, either by railroad or canal or road, much easier than you could in previous centuries. And looking at this map too, we still see our differential between north and south. We see the north much more connected with roads and canals. The south transportation network is still somewhat sparse. For those of you, I guess to tie this into some local history, if you're familiar with the Nashville area, the Natchez Trace Parkway follows the route of the old Natchez Trace, one of the early roads built in the south, connecting Nashville to Natchez, Mississippi, basically providing a shortcut. Instead of traveling down the Cumberland River, the Ohio River, and the Mississippi River to get to New Orleans, you could just get on the Natchez Trace, and it was a more direct route to the southern Mississippi and Louisiana instead of traveling by boat. And this, of course, there's parts of this road that are still in use today as well. So just another example. It wasn't just the national road. There were many other roads being built. Same thing with canals. There were many canals connecting the Great Lakes to the Ohio River and to the Mississippi River. By the time we get to the Civil War, it is possible to sail around all of the United States by boat. You can get in a boat in Maryland. You can sail all the way up the coast into the St. Lawrence River through the Great Lakes, and then of course Lake Michigan now being connected to the Mississippi River by way of canals. So you could go all the way around the nation by boat. And this transportation network, we've lingered on this for quite a few minutes here on purpose because it's very important. And here's the reason why. In 1800, it takes about 6 weeks to get from New York City out to the frontier, what it will eventually be Illinois and Missouri, this frontier territory out here along the Mississippi River. It takes about 6 weeks to get there, no matter how you travel, whether you travel by boat down the coast or you travel overland and then down the Ohio River. It takes about 6 weeks to get from New York out to the frontier. By 1830, and remember in 1830 we've got our first segment of the National Road, our Erie Canal is open, and we've got the railroads are just really getting started in 1830. So they're not really a factor then. But the Erie Canal and the National Road have sped up travel to the frontier now, cutting it down almost in half. So to get from New York to the frontier, it takes about 3 weeks now in 1830, as opposed to the 6 weeks it did 30 years prior. And here's the big change. By 1857, in the couple years prior to the Civil War, our trip from New York City to the frontier only takes about 5 days now, less than a week. A trip that used to take a month and a half now only takes a few days. And this is going to be important for several different reasons. One, it's going to speed up the settlement of these frontier areas. It's now much more easy for people to get to the frontier. It's much more practical. Keep in mind, a lot of people living in the eastern cities, as these cities grew and became more populated, a lot of people now have a stronger desire to move to the frontier. But prior to this transportation network, it wasn't really practical for a lot of people. But now it's easy. You load up your wagon and you drive down the National Road, or you get on a boat, or you get on a train and you ride out to the frontier. It's very easy to get there now. And when you get there, you're not going to be completely cut off from society. It's very easy to send a letter back home to your family in the cities. It's very easy for manufacturers to sell their products out here on the frontier. So out here on the frontier, you are not isolated. You still have access to all the benefits of the city in terms of goods and services. And of course, if you're a farmer, you're growing crops or livestock that you want to sell in the market, you now have very easy access to these markets over here in the eastern cities. The bottom line is, this transportation network is going to facilitate a very rapid growth and development of the United States, both economically and in terms of settlement in these new territories as well. And keep in mind, our Louisiana territory, which which has just recently become part of the picture in early 1800s, this transportation network is going to give people more access to this territory, speeding up the settlement process there as well. So basically, not only is it easier for people to get to and from the frontier and for goods and services to be exchanged between the eastern cities and the frontier, this has the effect of unifying the nation in a way that it hasn't been in the past. In the early days of the Republic, the frontier could have just as easily have been on another planet. It was some distant, far-off place that most people could barely even get their minds around. In the 1850s, though, it's a very real place. It's much more connected now to the older established parts of the country. So there's a greater sense of unity and connection across the country than there had been in previous generations. Transportation network is what helps facilitate all of this. Another reason the transportation network is going to be important is because America is in the process of industrializing during the early 1800s. Small companies are getting bigger. New companies are being formed. We're manufacturing things on a level that previously was not possible because of this industrial revolution. So we now have some goods and products to transport and distribute along this transportation network, which helps speed up the demand for these goods and services, which in turn helps contribute to the further growth of American industry. So it's all connected. The Industrial Revolution begins roughly around 1780 and extends on into the 1850s. And it's not like a sudden beginning and a sudden end. It's just this process of industrialization. And we're talking about mechanization, using machines to do work that had previously been done by hand. This process of mechanization is going to really revolutionize the production of man-made goods. And it roughly begins around the 1780s, and this period of growth, this initial period of growth, will start to taper off by the 1850s. We'll see another rapid growth later on in the 1800s, the late 1870s, 1880s, up through the early 1900s. But that'll be covered in part 2 of American history. We're more concerned with this initial industrial revolution. And when we talk about mechanization, we're referring specifically to the textile industry. While eventually mechanization, or the use of machines to do labor previously done by hand, will become a standard feature of all industries. Initially, it begins in the textile industry. And this is not really an accident or a coincidence. The textile industry was the most prolific industry at the time. When we talk about textiles, we're talking about cloth or fabric made from either cotton or wool, primarily. Everybody used fabric of some sorts. It was blankets and sheets, clothing, the sails on ships, curtains, everything, all kinds of things were made from textiles. So this textile industry is very prolific. It touches every part of society. So since it's the most prolific industry, the most demand for anything as far as manufactured goods is among textiles. So it's no big surprise that when we figure out how to make things with machines, that we're going to apply that to the textile industry, where there's the most demand. So the mechanization of the textile production is where the Industrial Revolution really begins. Initially, we're using ancient technology. The water wheel is an old technology. It's been around for centuries. We're going to apply this to this water power to operate these new spinning and weaving machines for the textile industry. And later on, we're going to start incorporating steam power into this picture as well. Just like we did with the railroads, steam power is going to be used in these mills that are producing textiles. Just to kind of set the stage here, when we talk about water power and steam power, we're talking about these mills. What you're looking at here is a diagram of an ancient technology. This goes all the way back into pre-medieval time. The idea of a water wheel being used to generate power to perform some kind of labor is an old technology. Basically, you build this mill along a waterway, a stream, or a creek, or a river, and the river, the force of the current turns this paddle wheel, which in turn drives some sort of shaft or gears or belts or pulleys, and it operates whatever equipment that you're using in this mill. Most mills prior to the Industrial Revolution were designed to either grind wheat into flour or other some sort of grain into flour, or they were used to cut logs into lumber, making boards. So a sawmill or a grinding or a wheat mill. These are the most common uses of this technology. But when the textile industry begins to mechanize, these machines are built to spin cotton into thread and to weave that thread into cloth. It's an obvious connection here to we'll power these machines using the traditional water powered mill. So when we'll start building textile mills. It uses the same power principle here, but it's driving a weaving machine or a spinning machine instead of grinding wheat into flour. But the same basic fundamental principles come into play. Once steam power is introduced, and steam power is introduced in the early 1700s, a British engineer named Thomas Newcomb, he develops the first steam engine, but it's not very good, not very successful. It's got a lot of problems. Later on in 1785, a guy named James Watt is going to develop a more efficient and reliable steam engine, and that's what we're looking at here, the steam engine developed by James Watt in 1785. Now, the use of steam power, or the concept, basically goes back to ancient history. The Romans were the first to theorize the use of steam as a means of generating power. But it was more of a novelty, and they saw no practical application for it, so the technology was never pursued. Not until the 1700s we see anybody really starting to do anything with it again. And of course, James Watt being the guy to really make it practical and reliable. And you see the obvious connection here. Basically, a steam boiler is a tank of water that's heated up with fire, and the steam pressure that builds up is used to drive these rods, which will in turn spin these wheels. And now we see a very obvious connection. We can replace our water wheel with a steam-powered steam-powered mill now, and produce the same type of energy, the same type of effort to drive our machines, but we're using steam power instead of water power. This gives us a little bit more flexibility. We no longer have to locate our mill right on the edge of a stream or a river. We can locate it further away from the river. As long as we have access to water for our boiler, then steam power becomes a very practical alternative to water power. And also, it doesn't rely on the current of the river, so in times of drought or when the river is not running very fast, we can still power our mill with steam power because the power delivery is more consistent than with the water mill. So let's get to the American part of the story now. Industrial Revolution begins in England. Steam power originates in England. American industries are going to be eager to start innovating and capitalizing on these new ideas as well. But there's a problem. These machines, these cotton spinning and weaving machines developed in England, are very closely guarded secrets. Basically, this is cutting-edge technology. In the late 1700s, early 1800s, this is cutting-edge technology, and it's very closely guarded. Machine-spun cotton is of superior quality to hand-spun cotton. Basically, the textiles that you can produce with these machines are going to be of greater quality than those produced by hand. Not only that, you can produce them in larger quantities, so you can sell more, you can make more. The value of these machines cannot be overstated. As such, they're going to be closely guarded secrets. To the point, so much so that in the 1700s, the English government passed laws making it illegal to export these cotton weaving machines or spinning machines, or even sell the designs outside of England. So these are very closely guarded secrets. America struggles for several years to try and catch up here. Since we don't have direct access to the technology, we try to copy it, we try to imitate it, just like Peter Cooper did with his locomotive. And in many cases with the same result. Our early versions of these machines are unreliable and inefficient, and we can't make it work the way England is making it work. That's all going to change with a guy named Samuel Slater. Samuel Slater was a mechanic in a British textile mill, Manchester, England. Basically, a mechanic is, of course, is a common career field today. But in the late 1700s, the position of mechanic was brand new. When they start using machines to do things, they need somebody to maintain and repair those machines. Hence the term mechanic. So the mechanic is a guy who is responsible for taking care of the machines, maintaining it, operating it, repairing it if it needs to be, and so on and so forth. Slater is a mechanic in a British textile mill. He decides to immigrate to America. He ends up settling in Rhode Island in 1789. When he comes to America, he brings with him this knowledge. Over the time he worked in this British textile mill, he memorized the design of some of these cotton spinning and weaving machines. And he brings this knowledge with him to America. He opens up the first water-powered textile mill in the United States in 1790. And using Slater's model, in the years that follow, several other textile mills will open up. Now the American industry has a direct access now to these designs and this technology, thanks to Samuel Slater. Of course, technically, according to British law, what he did was illegal, bringing the designs from England to America. But what's done is done, and the door is open now, and America can begin building its own textile mills. So in 1790, Slater builds the first one in Rhode Island. He employed mostly children workers because the work was simple and slow paced, so children were well suited for this. So in the old days, if you didn't do well in school, you ended up working in the mill. At any rate, growth is going to be slow at first. By 1800, there's only just about 7 or 8 mills in operation in the United States, of course, all in the New England area. That's going to change dramatically with a guy named Francis Cabot Lowell. Lowell is a Boston importer. He's a merchant. He's in the business of importing manufactured goods. On one of his trips to England to purchase more goods, he takes a tour of one of these textile mills in Manchester, England. Manchester was their chief industrial city. At any rate, Lowell is intrigued by these machines, and he sees an opportunity here to expand his business when he gets back. So he pays particular attention to these cotton spinning and weaving machines. He makes a lot of notes, mental notes. He also makes some covert sketches and drawings. Basically, this is industrial espionage. He's kind of stealing their ideas without them knowing it. When he comes back to Boston, he rounds up some investors, and they put about $500,000 into constructing the first modern factory in the United States. And this is right around 1814. This is the first modern factory because it uses mass production, and what makes it unique is the fact that not only is it using ideas of mass production, but it's the first factory in America where we see the entire textile manufacturing process taking place under one single roof. Basically, in his Lowell mills in Lowell, Massachusetts, again, a whole town is going to grow up around this mill. It's so big. Raw cotton goes in one end of the building, and finished cloth comes out the other end. So this is the entire textile industry basically in one single factory. Lowell's model of production becomes a standard for other mills, and by the 1820s, we see there's several hundred factories across North America, across the United States, mostly in the northern states. We see very little production going on in the southern states. This is still mostly a northern story. But several hundred of these factories pop up by 1820, and we've got a large industry now flourishing in the United States, thanks to Slater and later on Lowell, both pioneers in American textile industry. Taking a look at this, here's some of the technology. Here we have a cotton loom, or a loom, which weaves cotton thread into fabric. And we see here this the loom is an old technology, been used to weave threads into fabric for many centuries. What we're looking at here is just an innovation rather than a new invention. We're using mechanization to power this old ancient technology. We are now powering, see here the pulleys and the belts or the cables. This machine now is being powered by steam or water, and it speeds up the process. And in Lowell Mills, he takes it all to the next level. We've got here cotton or machines spinning cotton, raw cotton, into thread, and over here we've got machines that are weaving that thread into cloth. And you'll notice too in this factory, this is a sketch of Lowell Mills in Massachusetts. All the employees in this factory are women, and this is no coincidence. Lowell here again is pioneering things in American industry. He targeted unmarried adult women specifically for this task. There happened to be a lot of them, and Lowell's he's not thinking in terms of trying to give new opportunities to women. He's got a large scale factory. He's thinking big. I've got a large factory. I've got a huge operation. I need large numbers of laborers. And Lowell goes to what in his mind is the obvious choice. There's large numbers of unmarried adult women still living with their parents. And of course, he knows that once these women are married, they will start families, and they'll have their responsibilities will shift. They'll be the responsibility of their husband, and they won't be available for work anymore. But as adults, they can work. As unmarried women, they're unattached, they're untied to any other obligations, and they're the perfect laborer. Plus, too, most women at the time possess some knowledge of weaving and spinning. Again, this is a tradition that a process that took place in the home for many centuries, but now it's being mechanized and put into factories, and he's using the women who already have basic knowledge. They just need to be shown how to operate the machines, and he basically pioneers a new form of labor as well. These using primarily women as his labor force. This is an artist painting of Lowell, Massachusetts. Basically, we're not just looking at the actual mill where the textiles are being produced, but there are many structures in this Lowell factory complex, to include dormitories for all these unmarried adult women. There's a commissary and a church. Of course, Lowell is trying to reassure the community that he's not setting up some kind of a brothel here by putting all these young women to work. He's also attended to their every needs. He's provided them a place to live that's safe and secure. Their lives are still closely monitored, hence the church. And of course, there's their dormitories are supervised too. There's curfews and restricted visitation and so forth. So this is a big operation. This is not just a simple factory. This is a huge operation. In fact, Lowell, Massachusetts still exists today. If you went there, a lot of these buildings are preserved. They're now museums. But you can kind of get a feel for how large scale this operation was. Lowell, again, is a pioneer, in not just in terms of starting bringing weaving mechanization to America. His business model becomes a standard for an entire industry, and other industries as well will copy this. Once industrial growth begins to expand, other industries will copy Lowell's model. What you're looking at here, last little picture of our textile mills. This is actually a cross section of a water mill, but even using water power, these mills were very large scale operations. This one, of course, this cross section, we're way beyond just the basic wooden paddle wheel. They've diverted the river into a small channel that runs underneath the factory, and of course that smaller channel increases the water pressure, which means the wheels turn faster. You can turn more wheels, and of course these wheels, you can see, are all connected by belts and cables to various pulleys and shafts. And on each level of the factory, there are rows and rows of cotton spinning and weaving machines. again, this is a large-scale operation. We've taken a traditional form of labor that was done by hand, we've mechanized it, and we've scaled it up to mass production. And mass production and mechanization are the two key characteristics of this industrial revolution. Well, this growing textile industry in the United States and of course in England, which started years earlier, we've now got a massive demand for cotton. So again, most of the textile production is turning cotton into fabric. So this textile industry, both British and American, that has vast demand for cotton, we need to meet that demand somehow. Up until this point, most cotton comes from Egypt, India, and the East Indies, the West Indies, places where cotton had originally grown naturally. So cotton is grown in the United States, but in very small quantities prior to the 1800s. Most of the cotton that grows in the United States at this point grows along the coastal plain of South Carolina and Georgia, what they call sea island cotton. It's very easy to grow, but it only grows in certain areas, certain geography and climate. Now there are other types of cotton, what they call green seed cotton, which will grow pretty much anywhere. Well, at least in the southern United States, but it's got a lot of seeds in it, and it's very difficult to get the seeds out. So it becomes to the point where it's not very economical to grow this cotton. It's more trouble than it's worth. So prior to Eli Whitney and the cotton gin, which we're leading up to here, cotton production in the United States was a small percentage of the agricultural output. It just wasn't economical. It wasn't profitable. So very few plantation owners really got into cotton because it only grew economically in a couple of small places in South Carolina and Georgia. However, when Eli Whitney introduces his cotton gin, it's going to change all that. Whitney, by trade, was an engineer. All of his study and work experience was in engineering. But in the 1790s, he was working as a tutor on a plantation in Georgia. In his spare time, he tinkered around in the plantation workshop. He comes up with an idea for how to extract the seeds from the cotton more efficiently. And of course, here we see an illustration of Eli Whitney's cotton gin. It's a very simple machine. It's small. You could fit it on a coffee table. And you see here, it's a hand crank, a couple of cylinders with combs and brushes that are designed to comb out the seeds from this green seed cotton, this cotton which had been deemed unusable by cotton plantation owners. It's too much trouble. It's too much trouble to fool with, and they didn't make any money off of it. So nobody wanted to grow it. Well, now with Whitney's cotton gin, the de-seeding process becomes much more efficient. And to kind of put that in numbers for you, prior to the cotton gin, it took an average slave an entire day to de-seed about a pound of cotton. 1 pound of cotton. Now, of course, 1 pound of cotton is going to be a couple of cubic feet. So this is just how tedious it is to get the seeds out of this cotton. It takes a long time. So even if you had a large plantation with dozens of slaves all working all day, you're still not going to produce enough cotton to make any money. With the cotton gin, that same single slave working all day can now produce 50 pounds of cotton. What this represents is essentially a 5,000% increase in efficiency. And this is what's going to lead to the dramatic expansion of cotton production. One, because it's so easy now to extract the seeds from the cotton, plantation owners can grow cotton and actually make money off of it because it's not so tedious to make it marketable. And of course, it takes plantation owners about 10 seconds to realize that this device is so simple it could easily be scaled up in a much larger version, and of course can do the same thing in a much greater capacity. The bottom line here is that cotton production is going to expand exponentially and in every way imaginable. not just in terms of a single plantation producing more cotton now because it's quicker to produce, but some plantation owners will quit planting other crops in favor of cotton. Cotton becomes so there's such a demand for it in the British industry, and then of course now in the American industry as well. There's such a demand for it, and it's so easy to produce. Some plantation owners will abandon everything else but cotton. And what we'll see, another expansion we'll see is geographical. Cotton is no longer being produced just on the coastal plain of South Carolina and Georgia. Places like western Georgia, North Carolina, Alabama, Mississippi, Louisiana, cotton will eventually expand into all these areas of the American South, because this green seed cotton that was previously too much trouble to fool with now becomes very profitable. So cotton will expand dramatically across the nation in terms of volume produced and areas where cotton is produced. When cotton production expands, the demand for slavery will also expand. And what we're looking at here is a map basically showing the growth of slavery in the United States between the end of the 1790s and the Civil War. 1790, this is before the cotton gin. We see slavery basically contained within this coastal plain of the Chesapeake area and the Carolinas, a little bit in Georgia. And the red colors indicate a higher density of slave population, where the slaves account for more than 50% of the local population. So we see here 1790 slavery is confined largely to this region along the Atlantic coast here. We see, of course, slavery does exist in the northern states still at this time, but in much lower density. By 1830, of course, our cotton gin has been in production and on the market for about 25, 30 years at this point. We see slavery has expanded dramatically in the space of a single generation. We see all across the South now slavery is the dominant means of labor, and of course our high density areas are now more prevalent across the southern states, and we see, of course, through slavery diminishing in the north. By the time we get to the Civil War, of course, there is no slavery in the north at this point, but slavery in the south has become fully across the whole entire region. We see the pattern is still the same. These areas of high density, these are the cotton producing areas, and this is just an indication primarily of how cotton created a large demand for slavery. That cotton now is profitable. You can grow cotton anywhere in this region instead of just over here in South Carolina. So this is going to allow slavery to expand. What will end up happening is, even though the international slave trade has ended at this point, we will see a large-scale growth in the internal slave trade within the United States. What will happen is that as slavery is outlawed in the north, some people will sell their slaves. As we see demand for slavery increasing in the South, demand for slavery actually diminishes in these states of the upper South. Places like Kentucky and Tennessee, the western part of Carolinas and eastern part of Tennessee. These Appalachian regions, there's never really a large demand for slavery here anyway, but as demand increases in the South, the price of slaves, or the value of slaves, more than doubles. So a lot of these slave owners in the upper South who don't have a very big need for slaves, they start selling off their slaves to people in the lower South in order to make a profit. In fact, some people make a fortune just buying and selling slaves. They'll purchase slaves from small farms in the upper South at a bargain, and then they'll sell them to plantations in the deep South where cotton is in high demand, and they'll make a huge profit. And this is where the expression being sold down the river originates, because slaves in the upper South being sold down the river, of course we're talking about the Mississippi, to the deep South. And this is the first time we see slave families being broken up in significant numbers. Spouses being separated, parents being separated from their children, and so forth, during this time where there's a lot of volume in this internal slave trade, a lot of slave trading going on within the United States, even though the international slave trade has ended at this point. So the expansion of cotton, the demand for cotton, and of course the more efficient production of cotton also contributes to a dramatic expansion of slavery. So the role of cotton here cannot be overstated. It has a dramatic impact on our story, not just in terms of economics, but in terms of society and politics as well, because cotton will become a major force in these southern states. When we come back next time, we'll talk about how some collateral effects of this rapid industrial and economic growth, some other collateral effects of this next time when we come back. Until then, take care.